And the next test type is integration test. With integration test, we test the service's functionality. As opposed to unit test, which test code units, with integration test, we are not really interested in the code. We are interested in the service's functionality, and we don't really care how it's developed. With integration test, we try to cover almost all code paths in the service. The more code paths we cover, the more comprehensive our testing is. Of course, when the code is extremely complicated, it's not always possible to cover it all in the integration testing, and then we have to make sure the critical paths are covered. Now, it's important to note that some code paths might include accessing external objects, such as database and other services. And this is perhaps the biggest difference between unit tests and integration tests. With unit test, as we said earlier, we never cross the service's boundary, but with integration testing, we can and we often should. So let's look at a quick example, and as you can see, our orders service has a database which naturally is external to the service and resides in a separate process. As part of the integration tests, we must test the service's access to the database, which of course begs the question: what happens if the database or other external service used by our service is not ready, or is of a wrong version, or is simply not working for whatever reason? Well, in this case, we are going to use a thing called test double. Test double is an object or a piece of software that pretends to be the real object or service, so to allow testing. For example, in our case, test double will pretend to be the database so that our integration testing will pass. Now, we have three types of test double: fake, stub, and mock. Let's dive into each one of them and understand what they are. So let's begin with fake. Fake implements a shortcut to the external service. That means that it fully replaces the original object and provides a lightweight implementation, often within the same process. For example, if we want to fake a database, we can use an in-memory storage that is extremely simple and easy to use, but still provides some kind of storage. As we said, many times fakes are implemented in process. This is done to allow quick implementation and avoid inter-service communication that will just complicate things. Now, because the fake is implemented in process, it requires code change. The service's code needs to know it now works with the fake instead of the real object. So, in our case, instead of the external database, we now have a fake DB, which resides in the service itself and simulates the real database by exposing the same API. So this is fake. Next is stub. Stub is a piece of code holding hard-coded data. It's usually used to simulate data stored in a DB or a service that retrieves data from the database. The big advantage of stub is that it allows simulating data services quickly. Using stubs, we don't need to have a fully functional database with dynamic data or a service that accesses such a database, but all we need is a lightweight service holding a predefined data stored in the code itself. This allows for quick simulation of the data service and effective integration tests. With stubs, no code change required in the service we test. In fact, the service does not even know it works with a stub. From the service point of view, the stub is a completely normal service, returning completely normal data. So in our case, the customer's service, which our service calls for data, is being replaced by a customer's stub, which is a very lightweight implementation of the customer's service, holding hard-coded data. Note that the orders service has no idea something has changed, and that is a big plus. Next is the mock. With mock, we don't try to provide fake data using, well, fake or stub. What we do with mock is verify access was made. For example, if we have a piece of code that needs to access a weather service, with mock, we can make sure the access was actually made. This is useful when we are not really interested in the result of the call, but our test checks that our service actually called the external service. So, as opposed to fake and stub, mock holds no data at all. It's not needed. Now, similar to stub, Mock required no code change in the service we are testing. It's usually positioned outside the service, and the service has no ID. It works with a mock. Now, in our case, the mock will look like this. So as you can see, instead of the customer service, we now have a customer mock. The mock does not hold any data and does not pretend to be the service. It just verifies our service actually called the customer service. Okay, so these were the 3 types of test double, and your team will probably use at least one of them when testing microservices. Now, there are some more things to know about integration testing. First, the integration tests are implemented using the services API. As opposed to unit tests, they do not call methods directly, but run the service the same way it will be run in real life, using its API. In addition, and again, as opposed to the unit tests, integration tests are developed and run by the QA team, and not the developers. Since here there is no need for intimate familiarity with the code, these tests are run by the QA team, which is well equipped for such tasks. Integration tests, as with unit tests, should be automated. Since we try to automate our infrastructure, these tests will better be automated to accelerate deployment cycle. And how can that be done? Well, most unit testing frameworks support integration tests, so you don't have to look for other external tools. There are some interesting tools that might help here, but basically you can use the framework you already have. Okay, so that was integration tests, and now let's move on to the next test type.